Hello, my dear students and the rest of the learners. Welcome to part 43 of a 95-part series of tutorials in object-oriented programming in C++. In this tutorial, we are going to be looking on the topic inheritance, with our focus being on pointers to objects. My name is Mema JM, or you can simply call me Emily Swap. A base class pointer can point at an object of the derived class. However, a derived class pointer cannot point at an object of the base class. That is, a base class pointer can safely point at an object of the derived class without the need for typecasting. My dear students and the rest of the learners, it is important to remember that a pointer is usually a memory location that contains an address of another variable. In other words, what is stored in a pointer, as we said before in the series on C++ programming, we said that a pointer or a memory location is said to be a pointer, or a variable is said to be a pointer if the content in it is the address of another pointer, and therefore, or another variable, and therefore, through a pointer, you can be able to access the contents that have been stored in another memory location by a certain name, or what we call a variable. And therefore, when we talk about pointer in terms of or in relation to object-oriented programming, in reference to base classes and derived classes, we are saying that a base class pointer can point at an object of the derived class. However, a derived class pointer cannot point at an object of the base class. And therefore, a base class pointer, just as I've said, can safely point at an object of the derived class without the need for typecasting. However, a derived class pointer can be made to point at an object of the base class only possibly by typecasting. However, this can cause runtime errors. And the following is therefore a sample program implementing pointers in relation to derived classes and base classes. The name of our program is pointers objects inheritance, pointers to objects inheritance. We have hash include our stream using namespace standard. And then we have class A, which is the base class. And this base class called A has a variable or as an object, as a data member, not object, but it has a data member by the name X of type integer. And that member or data member is public. That's simply the definition of our class A. And then we have class B. And class B is a derived class. It is a derived class for class A, which is public. Remember, A is the base class, and therefore B is a derived class. And therefore, you can simply say that the scope for class B is class A. The definition for it is that it has a data member called Y of type integer, whose scope is public. So these two classes, the derived class A has a member called X. The base class A has a member called X, or the derived class B has a member called Y. Then we have our main function. In the main function, we have a declaration. And declaration for a pointer. The name of our pointer is a pointer. And a pointer is of type A. Simply, this is a pointer. This is a pointer that is supposed to point to class A. And then we have another instance. Remember, this is a pointer instance. A pointer instance. It is an instance, but which is of type pointer. Instance for which class? Instance for class A. And then we have another instance called B1. This instance is for class B. This statement here simply is a base class pointer that is pointing at a derived class object. Base class pointer B1. It is pointing at a derived class object, at a derived class object. So how is it doing that? Note that B1 is an instance for class B. And therefore, when we have the instance for class B, the address for instance B1, the address for instance B1 being assigned into the memory location for a pointer or for the pointer that's supposed to point to class A, it simply means that the base class pointer is now pointing at derived class object. Next, we are able to access base class member through the base class pointer. We are able to access base class member, or this statement is accessing base class member. It's accessing base class member and assigning into it value 10. It's assigning into it value 10. Remember, if you look, X is a member of base class, while Y is a member of the derived class B. And therefore, this statement accesses base class member, who is X, through the base class pointer, that is a pointer. And that's all with the main program. So the following is a demonstration on how to code, compile, and execute the program that we have looked at in C++ programming language. In other words, let us launch C++. Let's launch C++ program, and then we code this program. We execute it and see how it will behave. So what are we expected to do? So once we have this program, you can decode it or type it. You can type it in your word processor. In a word processor, then copy it and paste it into a C++ editor or IDE. Secondly, you can just write this program in your exercise book, just as you have done, and then you dry run it. After that, you launch C++ program and type your program into it. So how do we proceed? Let's proceed as follows. So what we are going to do is we are going to start our C++ program. That is Microsoft Visual C++ 2010. And then we are going to start a new project. As usual, we are going to follow the same procedure. So what is the name of our program? I'll just call it pointers. The name of our project is pointers to objects in inheritance. Inheritance. And then we are going to proceed just as we have been doing before. And I'm going to add a new item, which is code, and this code is a C++ file. The name for this file is pointers to objects inheritance. Then I'll click add. From there, because I have my program, which I've already written in Want, I'll just copy my program that I've already discussed, and then I'm going to paste it on my C++ editor. Here we go. Remember, if you have copied this program or you have typed it in your Word processor, like Microsoft Word, what you just need to do is to copy that program, paste it into a C++ IDE. From there, you save it, you build it, that is, you compile. If it has any errors, the errors will be displayed on the show output section. So our program has no errors. They are succeeded, meaning it has been converted to object code. We cannot execute our program by clicking on debug, then start without debugging. Why start without debugging? Because our program has no errors. You can see, as it stands for now, our program has been executed and it's not giving any output because there is no output statement in our code. So let's discuss each of the parts. Let's discuss each of the parts so that we can know what each of them does. First of all, just as I have said, APTR is of type A. Remember, A is class A. And therefore, APTR is an instance pointer to the class called A, which is the base class. It is supposed to point at objects of the base class. Therefore, it cannot access Y. Why can't it access Y? It can't access Y because Y is for the derived class. It's not for the base class. There is no member of the name Y in class A. Although the pointer for the base class, it is possible to access the data member called X, who belongs in the class called A, because there is a member of the name X in class A. Although the pointer for class A, for the base class, points at class B, which occupies 8 bytes, that is from X, and for Y, it is able to access the value contained in only the first 4 bytes. Therefore, the APTR cannot access an area in the memory that has not been allocated. Therefore, a pointer of the base class type can simply point at an object of the derived class. And derived class pointer can be forcibly made to point at an object of the derived class through what we call explicit typecasting. How is explicit typecasting done? It is done as follows. So the name of my program is typecasting derived class. And then we have hash include our stream. We have using namespace standard. Using namespace standard. And then we have our base class. We have our member X. We have our derived class B, which has the member Y, just as the other program that I've already explained. And then we have the main function here. First, we have the instance called A1, of type class A or type A. And then now we have a derived class pointer, a derived class pointer, and derived class pointer. Remember, the class is called B, and therefore the pointer for that class is B. So I'm calling it B PTR. From there, this statement is performing what we call the forcible typecasting in order to make the derived class B pointer point at the base class object, just as you can see. So the forcible, the typecasting is at the section which is in bracket. That is bracket B asterisk, you close. And that's all with the main program. So the following is therefore a demonstration on how to code, compile, and execute the program that we have looked at in C++ programming language. So simply, we are going to open our C++ editor and we type the program just as we have done for the other section. So as usual, we are going to open or launch C++ program, and then we copy this program and paste into it. And therefore, I'm going to start my C++ program. That is Microsoft Visual C++ 2010. Then I'll click on New Project. This Win2 console. And then I'm going to call it what? The name of my program is just here. It is typecasting derived class. So typecasting derived class. Typecasting derived class. That's the name of my project. And then I'm going to proceed and create a source file, which is by the name typecasting derived class. The name of my program, of my source code, is similar to the name of my project. From there, I'm going to copy my program because I have already coded it in Microsoft Word, or I've already written it in Microsoft Word. And then what I'm going to do for the purpose of this demonstration is simply to paste my program in the IDE. Remember, this section is the one which is executing the task for typecasting. And you can always ensure that you have aligned the various sections of your program by indenting them nicely. So you can type this program in your exercise book, or you can write it in your exercise book and then type it in your IDE, or you can simply type this program in your word processor, then copy it and paste it in your IDE for C++. Once you have done that, you have typed or you have copied it and pasted it in the IDE, you should save your source file. From there, you compile your program. Remember, compiling is a process of translating the source code into an object code. Now, it has been successful, meaning that our program has no errors. So our source code has been converted to object code, ready for execution. How do we execute? We click on debug, then start without debugging. Why? Because our program has no errors. And you can see the compilation has been successful. So that's how we do typecasting of derived classes. Remember to save your work, and you can always close your C++ program, close any other open document. And with that, My dear students and the rest of the learners, we have now come to the end of part 43 of the 95-part series. You can now continue and listen and watch part 44 of 95 on inheritance and constructors, or what we call initialization. Congratulations for learning part 43 of 95 on pointers to objects. You can access videos from the other parts in object-oriented programming series, as well as other computer or ICT videos by clicking or tapping on MLSWAP ICT YouTube channel below this video. Remember to subscribe to the channel by tapping on subscribe button below this video in YouTube if it's not currently reading as subscribed. For any further correspondence, kindly write it to us through the email emilyswap@gmail.com. Remember, you can also join MLSwap ICT YouTube channel as a unique member by clicking on join button that is already appearing next to the name of the channel MLSwap ICT. By so doing, you'll be able to have additional rights and privileges, and you can be able to access videos even before they appear in YouTube for the rest of the members. Thank you very much for listening to me, and God bless.